welcome back to another video. And yep, we're still in paper 1 with the same variant paper, which is February March 2025 paper 1-2. So the reason I picked this question is actually not that the question is challenging, it's actually a very straightforward and simple question. The reason I picked this is to show you an easy way to actually solve this. I know, right? An easy way to solve an easy question. Yeah, that's right. So you can use this method to any type of question that is asked the same way. You can use this in paper 1, paper 2 and paper 4. And trust me, it will save you a lot of time and it will help you see things clearly as well, and also help you to understand the question better, because it helped me a lot, especially it saved a lot of my time. So I believe it will help you as well. So without further ado, let's get into it. Question 18. A projectile is launched at 45 degrees to the horizontal with initial kinetic energy E. Simple enough. Okay. Assuming air resistance to be negligible, what will be the kinetic energy of the projectile when it reaches its highest point? Okay, wait, let me pick a color. Green. Okay. So they say the projectile is launched, and it's launched at a 45 degree angle to be specific, and they say the initial kinetic energy is E. Okay, so what are we going to do here is we're going to solve it using ratio method. So we know kinetic energy, Ke is kinetic energy, is half mv square. I think this is a very famous formula, right? Ke equals to half mv square. So we know that the m is constant. It's the same projectile whether it's initially or whether it's the highest point. The same projectile is being launched, so the mass is constant. The only thing that's going to change throughout the motion is your velocity. So I can safely say that my kinetic energy is directly proportional to my velocity squared. Right. So what we're going to find out, we're going to find kinetic energy of the projectile when it reaches the highest point. So I'm going to name that as KEH. H as in the highest point, and then divided by over KE, or I want to say it's initially. I think better I write it as I, right? Because they say it's initial. And since they're directly proportional, that means my highest point velocity should be written on top, and my initial velocity is written bottom. Okay. So this is how you write your ratio when it's directly proportional. What if, let's say, for example, x is inversely proportional to y? How would I write ratio for this? So for example, you want to find the initial value of x. So it's x initial over original divided by your y original should be on top. Then your y initial should be below. It should be cross because it's inversely proportional. Also, it doesn't matter whether you write initial value first on top, h first and below, it doesn't matter. As long as you are consistent with your values. If your h is on top and it's directly proportional, then your highest point for velocity should be also on top lah. But if it's inversely proportional, then it should be crossed. Okay. Alright, so you get the idea. So you can apply this for any type of question that asks you initial, final, or maybe ask you at this particular time, then they ask you, okay, what is the value at that particular time. If you can use an equation to do that, use the ratio method to find your final value, initial value, so on and so forth. It's so much more easier, trust me. So you're going to find what is this value, right? I'm just going to make it as KEH. Initially it was E. And what is your velocity at your highest point? So at my highest point, my vertical velocity is 0. I only have my horizontal velocity, which is V cos 45 degrees. So I set this to be V. I should have said that earlier, but yeah. I set the resultant velocity to be V. At my highest point, there's no vertical velocity, only horizontal. So the only velocity there is V cos 45. Why is it cos 45? So this is Vy, this is Vx. Is 45 degrees, and you do trigonometric, you will get V cos 45. So this will be V cos 45 degrees. Don't forget your square, okay? and V initial is just V square, cos V square. At this point, your resultant velocity at your highest point, it is V cos 45 because your Vy is 0. So your resultant is your horizontal velocity. Okay. And what will you get? You'll get Ke H over E equals to 0.5 V square over V square. This can be cancelled out. KEH over E equals to 0.5, and kinetic energy at your highest point is 0.5 E. There you go, and your answer is A. So if you are used to this method, you can actually just straight away skip from this to this straight. Because in paper 1, they're not going to see your working, but maybe in paper 2 or 4, if they ask you to show something and it's more than 2 marks or it is 2 marks, I think it's better you show your working lah, because it's paper 2 and 4. But paper 1, you can actually just skip from here to here. But see, it's so easy, right? The ratio method. You understand how the formula works, whether it's directly or inversely proportional. Write your ratio in that way. Sub in. Don't even have to think much. Use your calculator and bam, you got your answer. So, use the ratio method if they ask you to find initial value and they give you final value, or anything that they give you a value and you can use the formula to find a final value or value at a certain time. Use ratio method. Saves you a lot of time and you'll be more clear of what the question wants. So I hope this helps, because it helps me a lot during my time when I set for A levels. So I thought of sharing it to you, and I hope it helps you as well. And that's all for today's video. I'll see you in the next one. Take care of yourself, stay hydrated too, and bye bye.